Okay, let's dive right into this. Welcome to today's Explainer, where we're going to look at something truly transformative for anyone getting into algorithmic trading. We're talking about a procedural workflow that basically turns a cutting-edge AI into your own tireless 24/7 quant intern. If you've ever felt completely overwhelmed by the technical hurdles of setting up algorithmic trading, well, this Setup to Success roadmap is designed specifically to demystify the whole process for you.
Here's our roadmap for today. We'll start by meeting your new AI Quant. Then we'll set up the environment, connect the MCP server, run your very first backtest, analyze those AI reports, and finally, iterate for better returns.
All right, Section 1, meet your AI Quant.
So the core of this workflow relies on combining an AI, like Google's Gemini 3.5 Flash, inside an IDE like Anti-Gravity, with the Jessie trading framework. But, and this is the absolutely crucial point here, you have to understand how these two pieces actually talk to each other. That happens through MCP, or the Model Context Protocol. Without it, the AI is really just a glorified chatbot. But with it, MCP acts as this vital communication bridge. It literally allows the AI to directly access your local Jessie framework. It can read files, run the engine, and pull the results right back into your chat window. It effectively becomes your personal, always-on research assistant.
Moving right along, Section 2, setting up the environment.
Think of this phase as giving your new digital intern their own desk and, handing them the keys to the building. To get the Jessie framework talking to the AI, we've got to configure our local environment variables. First step, crack open your projects.env file. Inside, you just need to ensure two specific values are there. You're going to add the MCP_port variable, and then make sure you set MCP_log_n terminal to true. This simple, action-oriented text edit is exactly what exposes your local trading server so the AI can securely communicate with it. It's the foundation for everything we're about to do.
Oh, and here's a fantastic pro tip for your setup. In your project files, you'll see a document containing rules. These basically tell the AI where to look and what to do inside the Jessie framework. Now, if you rename that file from MCP_rules to agents.md, almost every modern IDE will automatically attach those instructions to every single new chat you open. This is a total game changer because it ensures your AI always knows its job description and you don't have to manually attach the rules file every single time you start a new conversation.
Okay, Section 3, connecting the MCP server.
This is the terminal execution phase. This is where we flip the switch and turn the trading server on. Let's walk through this like a quick over-the-shoulder tutorial, okay? Open your terminal. Step 1, activate your specific Python environment. Step 2, you just type Jessie run and hit enter. Once you do that and open your Jessie dashboard, it's going to give you an MCP address. Step 3 is simply to copy that address. Now, while the port usually defaults to 9000, 9001, and so on, it really doesn't matter. Just copy whatever address the dashboard spits out for you.
Next, you've got to paste that address into your IDE's MCP server settings. But, and listen closely here because this is a super common beginner trap, you have to watch out for the local versus remote configuration. Even though your Jessie server is technically running locally right there on your very own machine, you actually must configure the MCP setting as remote. Why? Because it communicates via HTTP. If you select local, it simply won't connect. Seriously, always choose remote for this workflow.
Right, Section 4, running your first backtest.
Now that all the technical plumbing is perfectly connected, it's time to actually assign our tireless AI intern its very first real-world task, building an actual trading strategy. When you prompt the AI, specificity is your absolute best friend. Listen to this example prompt. Create a new golden cross strategy, trend following, on BTC/USDT on Binance Perpetual Futures for 2024 using the 4 hours time frame. Do you see how incredibly detailed that is? For someone new to algorithmic trading, this right here is the golden rule. You must be that specific about the strategy type, the asset, the exchange, and the time frame if you want to get perfect, executable Python code back from the model.
And just like that, instantly the AI writes the code. It uses a fast and slow simple moving average for the crossover logic. But you know what's really interesting here? It's the risk management setup. The AI automatically utilizes the ATR, or average true range indicator. By setting a stop loss at 2 times the ATR and a take profit at 4 times the ATR, it basically builds in this fantastic 2-to-1 win-to-loss ratio right out of the gate. That means your winning trades make twice as much as your losing trades cost you. Pretty smart, right? It also conservatively decides to use only 10% of the account balance per trade to protect your capital.
Next up, Section 5, analyzing the AI reports.
Once the code is written, the AI uses that MCP bridge we built earlier to actually run the backtest locally. It's effectively grading its own homework, and this brilliantly illustrates how it doesn't just code, it automatically generates a performance report highlighting a Sharpe ratio of 0.68. Now, if you're a beginner, the Sharpe ratio simply measures your return compared to your risk. The higher the number, the better. A 0.68, it's not terrible for a first draft, especially alongside a 53% win rate. But the overall net profit was quite low because, as we saw, it conservatively used only 10% of the account balance per trade. So it's a very safe start, but it leaves a whole lot of performance sitting right there on the table.
Which brings us to Section 6, iterating for better returns.
So how do we fix that low performance? Well, this is where the true leverage of an AI quant workflow reveals itself. Instead of manual tweaking, you simply ask the AI to run and compare 3 more iterations to improve the results. And in response, it actually creates this beautifully formatted markdown table directly in your workspace. It tests different parameters, comparing that low-leverage start of iteration 1 against new, highly optimized variables in iterations 2, 3, and 4. You don't even have to guess what worked best. The empirical evidence is laid out right there in front of you.
And wow, the results of this automated optimization are striking. The AI identified that iteration 2 was the clear superior winner. It jumped the Sharpe ratio from 0.68 all the way up to 1.76. It even automatically restored the active Python code in your project files to the iteration 2 implementation. It's doing all that heavy lifting of optimization entirely on autopilot.
Now, for a quick dose of reality. During this actual test in our source material, the free Gemini API credits literally ran out. But you know what? The foundation was already perfectly laid. Taking the AI's optimized iteration 2, a final manual tweak was made. Because the AI had kept the max drawdown, meaning the largest drop in your account balance from peak, so incredibly low, it was safe to manually increase the position size to 2 times the current balance. That's essentially using standard leverage. The result? A massive 73% net profit while keeping that maximum drawdown safely contained at just negative 18%.
Which leaves us with this final, rather thrilling thought. We just walked through the basic workflow of asking an AI to write, test, and optimize a strategy for just a handful of iterations. But what happens when you remove those free tier limits? What happens when you unleash this setup to run rigorous Monte Carlo simulations, testing your strategy against thousands of random market scenarios, 24 hours a day, 7 days a week? The potential to find robust, highly profitable strategies is now entirely in your hands. Thank you so much for joining me on this explainer, and I really hope you're leaving inspired to go build your own tireless trading intern.